Using an HMI, otherwise known as a human-machine interface, is a very important middleman between humans and technology. Let's take a look at an HMI that we have in the Kings plant, specifically Building 9 Pistachio's main page. The first step to using any HMI is signing in with your username and password. As you sign in, you will notice that your username will replace the view-only mode. When in the view-only mode, you cannot make any changes or clear any alarms. You are able to visually see how the system is running and check the motor current settings, but cannot make any changes until you sign in. Once signed in, you should first begin to visualize the overall process that this HMI controls. Let's walk through the flow of this particular HMI. Before we can pasteurize the product, we need to store it in the hoppers that feed the preheater. To fill the hoppers, we need to open the corresponding gate to start the cable vey motors that will deliver the product into the hoppers, and then start the syntrons under the bin dumpers. Then the product that is inside the bin dumpers will drain into the cable vey and deliver the product into the hopper. In order to do this, we need to go to the control screen and choose the hopper we are filling and what product we are filling it with. Once this is done, if the motors, gates, and syntrons are all in auto, all the corresponding gates will open and the motors and syntrons will turn on. If the hopper already has product in it, we can choose to discharge it out of the hopper and into the preheater from the same control screen. In order for the system to run, the motors need to start in order. Motor 080002 will start before motor 080003, and motor 080003 needs to start before motor 080004. And in turn, motor 08004 needs to start before motors 080101 or 080201. Motors 080101 needs to turn on before any of the east hopper syntrons, or motor 080201 needs to turn on before any of the west syntrons hopper. What would happen if one of the east syntrons turned on before the motor 080101? If you guessed a huge spill of product on the ground, you guessed it correctly. There are always negative consequences when a system does not start in the correct order. Now that we have discussed the big picture of how the system flows, let's dive into the individual motor. Before you even click on a motor, you can get a lot of information based on its color, or if it has any warning indicators by it. If you see gray, it typically means no feedback or loss of communication. If you see purple, the motor is disconnected. When a motor is in red, it is an alarm. A blue motor means that it is in auto and not running. A green motor indicates that it is in auto and running. A yellow motor means that it is in manual and not running, but will be flashing green if it is in manual and running. Once you click on a motor, you are able to view more settings, such as the FLC, otherwise known as full load current setting. This setting is important because it is the amount of current the motor can receive before thermally overloading. Another important setting to monitor is the thermal meter. This meter lets you know how close the motor is to overloading, which is a thermal failsafe in order to protect the motor from overheating. When a motor overload fault occurs, it prevents a motor from running until it is reset. Even when a motor is running close to its FLC set point, it is only a matter of time before its thermal overload trips. Notice, when you click on motor 080002, you see a VFD, which stands for Variable Frequency Drive Setting. This setting allows us to control the frequency at which we want the motor to rotate. This is directly related to the RPM, or speed of the motor. If the FLC gets near or above the FLC target, this motor will likely trip. If a motor has any exclamation indicators, it is warning you of the thermal temperature of the motor due to its current FLC status. The motor's FLC settings and thermal percentage are directly related. As an operator, you are given the ability to turn off a motor or put it in auto or manual. If any errors occur on a motor, it will typically be highlighted on the right-hand pane. You can use the reset button to clear any faults or alarms, but remember to try and troubleshoot the cause for the error before blindly resetting this, as it can sometimes cause further damage to a motor. In summary, it is important to understand the process flow of the system you are trying to use an HMI on. Also, there are essential things you need to be able to monitor as well, such as motor startup, motor color indicators, FLC settings, thermal settings, and any alarms or faults associated with the hardware. An HMI is a powerful tool, and with correct use will make your job easier and more efficient daily.